Well, hello. We're back to streaming for 1 hour maybe today. I'll be trying to, first I'm trying to make the text appear, but after that, selection algorithm for ensemble learning. Right, so today I'm working on this selection algorithm for ensemble learning. So just once I manage to make text appear over there, why doesn't it appear? What the fuck is going on? Hello? It just doesn't work. There's no free type here. Free type 2. Oh, okay. Yeah. Hello. Oh, so that works. This one doesn't. Alright, whatever. Let's try. So, but why does this work? What's different with it? Selection algorithms for ensemble. Oh, it doesn't work again. Maybe it just doesn't like that. The content. It just doesn't like the content, right? Why is it not working? Enable. It's too big. Oh, because it has to be there. Alright, great. So OBS works this time. Oh yeah, by the way, we have noise. People are doing reparations or something. So let's see, does it work? Then let's get into it. Yeah, seems to great. Good old 0 viewers. Let's put some chill music and get into it. Maybe this one. So yeah, that's just the reality. I mean, I have noise cancelling, but you don't. So you'll have to live with the noise from upstairs. Alright, so what am I trying to do? So what do I mean by selection here? Let's say I go to online Blackboard. I said Blackboard, they give whiteboard, but that's fine. Hey, Miro, does Miro have? That's the way. But I want it to be black. Background color. Alright, let's see. How shitty is the software? Where's settings? Settings. Where's settings? Settings. features, but we don't have color. That's interesting. And maybe in text somewhere. Let's so different color. White. No, let's look at that. Okay, so I have white, and what about pen? How do I pen color? There's no way I cannot change the color of the pen. Lasso? No. Smart drawing. Mirror pen, change color. Pen. Use presets. Pen. Right, how do I change the color? Okay, so that's red. Then okay, so he pressed on. Oh, alright, great. How do I select? Yes, alright, great. Alright, so what's the idea here? So we have this project that I'm working on, which is a neural network basically that predicts multiple times. So you have like ensemble learning basically, and the idea is, okay, so you have a model here, right? My typing is not the best. And then you have some X input, and then you get some Y input, Y. Alright, and that's the basic idea. But instead of this, what I do get is multiple ones, right? Get like many of them. It's a big Y. Alright, and the idea is, okay, how do I combine this to get a single final one? Let's call this aggregation. Okay, should use text then. Aggregation. Question is, okay, how do I do this? Right? And this is the basic idea of this. And the most basic idea here would be, maybe the music is too loud, right? The basic idea is, okay, so how do I define this f ag that takes basically a list of predictions and the simplest thing you can do here is just make an average. So if this is like a regression, you can simply take the average, and that will kind of work, and it works quite well actually. And this is what we've been doing mostly. And in some other paper from before that we published, we did a bunch of other things. So another thing that you can do is this selection. So now there are two things here. One is when you know like some metrics for each of these y, and the other one is when you don't. So yeah, the question is, can you do this selection with labels, or can you do it unsupervised? And doing average is unsupervised obviously, but well, you kind of are prone to outliers, right? So if one of these predictions is very bad, it may influence all. What we did in some other paper is that we actually trained the secondary model here, and this did the selection based on these inputs, and that also worked quite fine. I mean, it was a proof of concept, but it worked fine. Another idea that my professor actually told me is maybe I should get like the average of this and then only keep those that are close to the average and do the average of those top k closest to the average. So the idea would be like you have kind of like this, right? What happened here? I guess you have a bunch of them. Alright, we have a bunch of them. Now let's get a few more. And then you get the average of them, which is like this guy here. Let's call it average. Alright? And then, so this is like a k-means kind of thing, right? And then basically what you do is in the next step, let's say what selection is V. Select this V, right? So this is step 1, and then you kind of put this here. Alright, let's make it slightly smaller. We put it here, and yeah, the thing is now let's say I have some of them here. Like that, it doesn't. I have some of them here, some of them here. Alright, and the question is which are the closest ones in terms of some distance. So let's say this is the radius that you care about. I mean, maybe it should actually be a proper circle, but you get the idea. So let's say this is the radius. Right. And basically you will kind of include just this, right? And then the result will be like the average of this, which is probably here. Right, and this is your final prediction, and these are like cut. That's the basic idea. So this is step 1, this is step 2, and this is the final result. So this is the idea of using like the average of averages based on some distance radius, right? Yeah, let's put this. So you put this here, right? What I want to do today is something simpler than this. So this will be for next week. So for now, I kind of want to make the average. So what I did, so my code already does this, and I already have some numbers, but it's not generic enough. So what I did is I went on the test set of this dataset that I'm using, and I got like 100 predictions for each test point. So that dataset is actually not that big. It has like only 100 and something test points. This transcript dataset that we've published in another paper. So you only have 116 test cases, and they kind of look like this. Yeah. You have predictions like that are like this, like semantic, the yellow-green box here. And I got 100 of each, so that means I have 116 times 100 predictions. So I have what, the 11k predictions, right? And basically that means I have like 116. So I have 1, 2, 116. It's supposed to be a 1. Not very good at typing with the mouse. And for each of them I have like one prediction, 100, right? So I have 100, and you get this for all of them. And the purpose of this is so I can use, maybe I can do the selection. I also have the ground truth, so I also have access to this, which, you know, this is only for evaluation usually, but I have access to it as like a proxy, let's say. Shouldn't use this in a real setting because this would leak, but now I can use it to like guide my idea. What I could do, which would be a bit smarter than using this, is have a secondary set, which is this validation set. Actually it's not written here, but there is a validation set in this train, in this 12k. There's like a 600 and something data point that's for validation. I could use this to have the same setup as here, right? And I could then find a way to learn which one to pick from this 100, right? The problem is that this is a combinatorial problem, I think, or I think it's something like 2 to 100 possible combinations that you have, because you can have just 1, and you can have 1, 2, 1, 3, and so on, and you can have 1, 2, 3, right? And then at the end you have like all of them, 9, which is, well, not very good. And this is assuming that the aggregation function doesn't care about the order, right? So this one is equivalent to this other one. If the order also matters, then you have even more of them, and yeah, this is not feasible. So one solution that we did back then is the following: is that we ranked them based on the individual score. So we use the ground truth, which is what I want to do today, and you get like a score for each of them, right? So this one has like a score of 1, this one has a score of 2, this one has a score of 3.5, and so on. Then you rank them. So you get like 1 to 100, and some has a score of, so you have a score here. Alright, and you have a score of 1, 1.5, 2, and so on. And you sort them. Alright, and after you sort them, you get basically the same thing, but you have them in some order, right? So it's like 1, 5, 100, 2, and so on. Last one. And the first one will be like the best performing one or the least performing, depending on how I sort, and the other one, like it gets worse and worse. And then maybe I can make averages, so you just use the first one, the first 2, first 3, and so on. I mean, this one should be included here, so you can do this, and that means you would get 100 scores, which would be top 1, top 2, top 3, based on the feedback of how well they perform individually, right? So you just pick the best individual performers, and then you add them to the average. And this is what I want to do today. So I already have these scores. I did this yesterday. Let's see how this looks. So, and you see this is the code. So basically I have this script. Let's all run on this server. Right, so I have export, if I remember, yeah. So I just exported, as I said here, 116 data points, 100 predictions for each, and I exported them to this directory. Where is it? This directory here. So this is where all the predictions are. Right, you can see it's like 100 of them, and yeah, basically I think I can do 3 or not. Yeah, so these are the predictions basically, and for each one of them, let's say Norway 20 whatever, I have like 100 predictions, right? So each of them are individual, and then I have some scores that I exported, and the scores are here. So this is every data point, so it's 116 rows, and this is like version 1 to 3 all the way to 100. Right? I mean, it's from 0 to 99, but yeah, you get the point. And you have some scores here. So now, the next thing I have to do is to sort them, followed by averaging. So this script that I did here, this is where it does the individual predictions. Now, I have some older code that kind of did the same, but it was a bit messy, like the code itself wasn't very nicely written, so I'm just gonna rewrite this. So what I want to do is I want to have like another CSV here that would do the following. Would have like the name and then would have like here 1, 2, 3, and this would be like top 1, top 2, top 3, right? And we would just do averaging here. So let's do that. So this is individual predictions. All right, so output here, which is here, and then maybe let's add a parameter called methods, maybe algorithm. Let's call it algorithms. It's like have one or more algorithms. And these are just some hard-coded stuff for class weights and so on. This was a bad idea. Basically, we put some weights on some classes. Some of them are more important than the other ones for the final score. And I think this was a good idea because now all our evaluation has to carry these arbitrary numbers. And this since stuff I'm not using it anymore, but it's fine. So let's all the algorithms have to be in the following. So algorithms any algorithms for Alright, and now I have the following. So if greedy selection I always have to carry the following things: spreads, GTS, spread names. So these are the 100 predictions, these are the ground truth, these are the prediction names. Should I care about this? Maybe not. Maybe not prediction names. And these are the scores. The scores are correct here. Okay. Yeah, I should do that. Just making sure that these are not broken. Yes. Alright, so we have greedy selections. These are the scores equal. And I have to probably also say greedy selection. I also need like a function. I'll probably keep the average for now. But yeah, later let's call it greedy selection average. Yeah, just to keep things simple for now. So we have these scores, and I want to always do the following thing. So this is an if statement. So I kind of want always to have this if, not rest path, basically the same here. Selection. something like this. I think it's nice if I keep the following scores equals this. Means I probably need to pass the weights also, or not, because I'm using aggregations here. I'm trying to say is with this higher use thing, things are already you only have a score for each prediction, but in truth you have a score for each class. So the thing is, you have a score for land, how good did you predict on land, how good did you predict on forest, and so on. So you have 8 of them, but you do like this dot product, so you get a single number at the end. Ideally this CSV file would have like a prediction for each class, but this would just make this CSV like 8 times larger, so I'd have to have like 1. So for each row, for each prediction, I'll have to have like a class here. And that would probably be the best way to do it. But it would complicate things. So I chose to actually have a single intersection of a union score, which is aggregated by these weights. So this is why I'm passing this here, evaluate individual prediction. But now all the things below here, let's say all the algorithms below use only a single use score after dot product with class weights, reducing with class weights. So I don't need the class weights anymore. So this should be like it, right? Scores, and then maybe I do. Yeah, somehow I don't like all this contraption here. But it's fine. Yeah, maybe I do this. You have this, and you have greedy data from scores, data names, and you do CSV as path. Right, and you do this else, greedy, let's call it greedy. Yeah, greedy one. Do CSV as path, let's call equals 0. And let's have this. Very verbose, but I have to score 3 predictions, and I put this here scores that shit there. Otherwise loaded 3D selection average. Let's make it like this. Predictions. This Alright, so this kind of is the full boilerplate. Now obviously I don't really like the way it did it, but I will see later if I factor this into something nicer. So do I have any functions here? So I have this mean, do I even use mean? 3D selection. Let's 3D selection algorithm. Or I think it's called average, right? Average. And we have predictions. It's a list of predictions. We have ground truth. It's a list of ground truth. And we return. What did I say that we return? We return basically an array, a two-dimensional array. This is not true here. After dot product. Yeah. The original idea was to return per class and do the averaging later on, but I didn't do that. And we return the same here. So please, let's copy paste this. After the selection. Oh my god, I just keep pressing some button. Source values and then average aggregation, adding one by one, prediction, one prediction. Alright, with C classes we don't have this. We have SNK from predictions. Alright, and you do return this basically. Cool. So let's have here this. Alright. What I'm thinking about this is a data frame. And I'm storing it as a data frame for convenience. But I think here I don't want a data frame. And here I want a numpy array. And this is just values, maybe. Let's see. Alright, we're finally running this bad boy. We're running on the server. Actually, how do I kill the tab? I never remember. It will be W. No, that's not it. I don't know how to kill a tab. Kill a tab in Linux. Control B C. Oh, that's great. So, X, Control B X. Yeah. No, what I want to kill, like, not a current one. I want to kill another one, or maybe it's just broken. I start from 1, but maybe Control D doesn't understand that. Alright, so evaluate top K. Alright, so this shouldn't do anything because I didn't put the selection algorithms thing, so we should just actually now I need to do something. Let's modify. So this should delete the files. And then you should just not do anything. So you should run this part of the code, which reads, and then the evaluation will be skipped because I already have the IIS file, so nothing is supposed to happen over there. And then this part shouldn't run at all because I didn't put it there. Hello. Minus. Oh, it's smaller. Oh yeah, it's smaller. Should be bigger. Okay, so let's use a subset of I could get that tutorial here, but or here or globals. No, not all are in that. Assert all. I think I messed something. Assert all. Is all. Okay, so it's loading the files. Remember, it's like 100 predictions for each of these, so it takes a while. And it did nothing. It loaded them and it just went over. So now if I put in algorithms, greedy selection, no, it's what do I call it? Greedy selection average. It should go into this breakpoint. Question is these values. Alright, that's what I kind of want. Oh, is this a numpy array? I think it's a numpy array, right? Just they changed how it looks, I think. Oh, it's a numpy array. Yeah, that's exactly what I need. So that means if I go here, okay, so I'm in greedy selection. I'm here, which does nothing. So I have preds, which is the predictions. Which is right, which is also list IOs, which is numpy array. Great, so let's sort them. And I need to arg sort, right? So that's IOs, that's I think it's arg sort 1. Yeah. Sending equals false. So what is sending? Arg sort numpy. Order stable. I just need to revert it myself. Axis equals 1, because I think, yeah, because it's supposed to be intersection over union, so that means radius of 0.54 is the smallest one, so this one should be slightly larger, right? So how do I revert it? I think I need to do this kind of structure. one. Yeah, so no, it's reversed. Alright, so arc sorter is arc sort x is equals 1. First one as the highest high. Alright, so let's look a bit at how the first row looks like. Yeah, so you can see like the highest performing one has 0.651 and then it just goes downhill from there. Alright, cool. So let's do the top case. So that means I have to do the following. For yeah, I think I can just do this. I can take that. So I have for I prediction ground, but it's not this. So it's for I access inner ticket when the arc sorted is like the selection average. This is the first, this is the row, and this is the indices. Alright. Great, and now I need to go through each index. Right, so that means I need to do something like this. So I need to do this breadth, this G, and this GT is fine. So yeah, I need to do this for J in range. So how many of them there are? I have this GT equals which is probably why I could do this, I guess. I just complicate my life if I do this. Maybe. Right, because the GT is the same, so that doesn't matter. So go one by one in this. Go one by one. Add one prediction every time and evaluate them with average ensembles. So these predictions is basically breadth of y of what is it? Excess this. Let's maybe call it. Yeah, I think it's fine. Something like this. Let me set a breakpoint here. If like this, let's set a breakpoint here. That means I should have 3 predictions here. So this thing should yield. I think I made an error here. Or not, I didn't. No, it's fine, I think. And wait, there. It's a bit slow. Oh, I messed it up. I went J here. Yeah, so I want to stop when I have a bunch of predictions. Maybe I should do a smaller n, but I don't want all of them anyway. So let's say access. Alright, so that means this thing should give me cleanup Oh, it's yeah. Wait, what? Interesting. How do I do this then? Do I do it like this? What? Yeah, because I want. Yeah, basically that means if I want this, we will have 100 of them. Yeah, but I will stop. Yeah, so this needs to be +1. Yeah, at the first iteration this wouldn't take any, and at the last iteration we will never get all of them ever. Alright, so these spreads should have 3 values. Because now we have basically this. So these are the indices of the most performing ones. You can see here, it's like the first 3 of them. So, and these are their predictions, right? And just like some maps, so that there's nothing special about them, but we know their scores. So you can select some differences. If you have a 0, 1, 2, and you have 1, 1, 2 here, it's not like they're identical or anything. Alright, so we have these maps, and now what I want to evaluate them. So that means I should be able to just call this bad boy here. That's not necessarily true. Still need the weights, don't I? Because I need to do the evaluation here. I still need the weights. Alright, so that means now I need to do basically just this thing. One question that I've had is what the type is this? Is it long? Do I need to put long here? Maybe not. Because for sure I don't need it here. So this is this spreads. What about GPs? Suint 8. Do I need it? Let's Alright, cool. So you have this crap here. This is not needed. Alright. If spreads have... Oh, because I need to average this, right? That's the whole point. Not average like that. Where did I argmax those? I don't think I should. Hold up. Load all files. I don't think I should argmax them. Load one. I don't think I should do this. Holy shit. Great. What was the right before? Yeah, this is interesting. So I have load all files. Kinda sad that I never did this before. Maybe I could do this. Okay, cool. So that means I'm moving on a bit. That means I should have an argmax here. This is wrong. I need to fail. It failed exactly what I said. Okay, so I need to do the average. That's exactly what I didn't do, right? I need to do the average. How do I do the average? This is actually not that hard. Spreads average equals the spreads from between 0 axis, whatever. Yeah. Save it. This is spreads average. And this is not equals, it's minus 1. Yeah, some reason this thing it's like this. And this is correct. So it was average, okay. Okay. Now this one should yield a result. Very well. And is it better than 0, 0, 3? Sorry, it is 0655, which is better than 0651, means the ensemble of these three yields a better result, which is what we want. Cool. Alright, then I need to do the same. I need to store it here. I have one of these bad boys, and then I need to do iOS day. What the fuck I do here? Makes no sense. It's always j equals this bad boy. Turn minus of numpy. Turn on 3. Let's call it res. Like res. And maybe here. Res. Just for the convention, res is the return value. It's return value. I don't like return arguments. Even if it's slightly more inefficient. And this should be the inter code, right? Well, let's let it run. See what it does. So it should run for a single prediction, should output a CSV file. Okay, my cat's scared. The shit out of me. Alright. Now let's see. Does it do anything? Maybe I should do a secondary TQDA. Just so I see it trying. I put here range. And I put, what was it, level? And you can make a level here. Let's try it. Let's see how if it works. What? You don't like that? What happened? Strange, not work. Not sorted x this. Oh. How did I change that? This is action. No, what was it? I changed that. Sometimes do happen. Alright, so now we should have a progress bar here also. There you go. Not the fastest, but yeah. The question is, can I do this in parallel. Because I probably can. Selection average. There you go, minus 10k. Nice. You did it. Oh, this. Put it here. Alright, I don't like how slow that is. How do I make this faster? I need to run this for loop parallel somehow. Yeah, something like this with thread pull. Yeah, because I can get this shit here. Very easily, I think. I have to call this crap somehow. You know what? Maybe I should just let it be. I can just let it run. Let's see the scores. I have 651, 651, so this is when using 1 and 2. I meant the first ones, which is, I mean 6, 5, you know, the sorted ones. And then 6, 5, 6, 6, okay, oh, it goes 6, 6, oh, what was the best one here? I think it goes downhill at some point, 6, 6. Using the best 9 of them, and then it goes downhill probably. Yeah, it's what I was expecting. Here's a small bump again. Oh, it actually increases again with. Alright. Kind of stabilizes here, but it probably goes downhill after you add all the add-ons now. Yeah. This is interesting. Right? This could be. This is a nice plot. So it goes up, it goes down, and it goes up, it goes down, it goes up again a bit, and then it goes down. It's like these two hills. Can I visualize that? Maybe I should visualize that. Let's see. It shouldn't be that hard to make a very small plot. Average CSV index all equals 0, display s, and should just do show as values or plt plots, plot I think, or value yes. Yeah, so it goes up, it goes down, it goes up again, and then it goes down somewhere. Stabilization here again, but then it goes down. So when you have the very worst ones, it just goes down. Interesting. Cool. Still irks me that this is not parallel. So let's commit this thing. So I can like preload all this crap. This part here is fixed. This is the changing one. But you always need to do the, not here, but here. Let's do the averages. And then you pass the averages. Why don't I do that? Let's say this averages equals zeros, one breads, 0 no, it's not that, it's zeros like breads 0, right? Some shit like this needs to be. But it's not this either. It's supposed to be basically zeros, then breads 0 shape. Right, this is the D type. Maybe it's not float authority at all, because I do the average and then rotate. That means it's 1 equals this. Yeah, right, so that means I can be here and I should have the averages in memory right now, which would allow me to this. What the fuck happened here? Oh, even the averages take a lot. So that's not a good idea. Never mind, that's not a good idea. I have a better idea. Oh. Sorry for the noise. So basically what I need to do, I need to have this as a do-one kind of crap. Do-one, breads, GTs, IJ, or Means I could probably use this thread bull crap. Can I? All thread files. These are the arguments. I just need to create all the arguments. Here, do this here, you pull that map. What do we do? One. Absolutely not. I think it's the same, right? It's the same. Yeah, it is, because here it is rounded. Same but faster, which is what I wanted anyway. And then I can do this rest. didn't save. I hate when this happens. Oh my god, don't save. Fuck. Cannot say if it's identical, that's the most annoying part. I'm not sure if this runs in order. Let's see, for n equals 5, is this faster? What I have to do just to make it right? It's a bit annoying. I mean, I wish there was like a parallel for some crap like that. It's definitely faster, but it's just about it takes like 7 seconds before each move there, which is portion faster. What I don't like about this is that it's not like before. So something changed. Like 6581. Maybe it didn't. What? Some of them get up, some of them do this weird crap. Hello? I guess my system had this before. Alright, cool. Yeah. Star map crap is not nice. Maybe I should do this. Maybe this just works. Oh, star map. Yeah. This work. Because this is just a bit better. It's ample. guess I can even do this. Was that a for I loop? It was a for j loop. Alright, and now I just have this crap, which I think it's fine. Probably this, right? Yeah, this is the closest I can get to something that looks nice. So this cool. That was the first one. It's consistent. This one goes up, goes down, then goes up. So weird. Cool, and I will just let it run for all of them and get the results back. Yeah, this annoys me, so I will just let it run. Can it be none? Okay. Yes, it can. If I use threads, how do I do it? Some shit like that. that's all. Should I should go. I have some appointment, so bye bye.